Hello students, today we're going to look at section 8.5, which is factoring polynomials using the greatest common factor, GCF. And there are three sections to this part, so we're going to go through each section individually. And the first part is when we have binomials and trinomials. So we're going to look at what we do to factor out the greatest common factor of binomials and trinomials. The first example we're going to look at is 27y squared plus 18y. When we factor out the greatest common factor, we've got to find the greatest common factor first between all of the terms that are in my trinomial, polynomial, whatever. Okay, so here I'm going to start with the coefficients. What's the greatest common factor of 27 and 18? 9 is the greatest common factor, so I'm going to write down 9. And what's the greatest common factor of y squared and y? I'll give you a hint. The greatest common factor of a variable is the variable with the smallest exponent. I'll say that again. The greatest common factor of variables is the variable with the smallest exponent. So I have y squared and y, so the greatest common factor then would be y, because it has the lowest exponent. So now what I need to do is I need to take both of these terms and divide it by 9y. So basically it's a reverse of the distributive property. So I take 27y squared and divide it by 9y. We'll start with the coefficients. 27 divided by 9 is 3. And y squared divided by y, remember when we divide the same base, we subtract the exponents. So y squared divided by y is just y. Because y to the second divided by y to the first, 2 minus 1 is 1. And now I'm going to take 18y divided by 9y. So 18 divided by 9 is 2, and it's positive, so it's plus 2. And then y divided by y cancels out, so there's no y's left. So that is the final answer to factoring out the greatest common factor of 27y squared plus 18y. The greatest common factor was 9y, and the two factors are 3y plus 2. Our next example is a trinomial, and I need to figure out what the greatest common factor is of the trinomial. I have negative 4a squared b minus 8ab squared plus 2ab. So let's start with our coefficient. What is the greatest common factor between negative 4, negative 8, and 2? You're right, it's 2. Now, because this leading coefficient is negative, I could factor out a negative 2 if I wanted to. It doesn't matter in this case. You can leave it as positive, you can make it negative, it doesn't matter. I'm going to factor out the positive 2. So I have a squared, a, and a. And so the greatest common factor of my a's would be just a. And then I have b, b squared, and b. So the greatest common factor for my b's would be b, because it's the variables with the smallest exponent. Okay? So there's my greatest common factor of all three of those terms. Now I divide each one of the original terms by 2ab. So negative 4 divided by 2 is negative 2. A squared divided by a is a. And b divided by b is 1, so I don't put anything. And then I have a minus sign. Negative 8 divided by 2 is negative 4. A divided by a is 1, so I don't write anything. And b squared divided by b is b. And then plus 2 divided by 2 is 1, a divided by a is 1, b divided by b is 1, so 2ab divided by 2ab is 1. In this case, I have to put the 1 because it's the entire term that's being divided by. So 2ab divided by 2ab is 1. And that would be my final answer. Now, if we wanted to work backwards to check this, I could do the distributive property. 2ab times negative 2a is negative 4a squared b. And 2ab times negative 4b is negative 8ab squared. And 2ab times 1 is 2ab. That's always good to check yourself. Go ahead and draw a squiggly line under all of what you've just done, because we're going to go to section B. And section B is factoring out the greatest common factor from a polynomial with 4 terms. Okay? So I have an example of a polynomial with 4 terms. 4qr plus 8r plus 3q plus 6. Now when we're dealing with polynomials with 4 terms, we have to group them into 2 sets of binomials. So I'm going to take the first set of binomials, 4qr plus 8r, And I'm going to take the second set, 3q plus 6. Now here's something that you're going to want to identify. If the plus sign is in front of the third term, then the plus sign stays outside of the parentheses. If that was a minus sign, the minus sign would go inside the parentheses. We'll get to one of those in a minute. So now I have two binomials, and I go back to what we did in section A. I find the greatest common factor of the first binomial, and that would be 4r, okay? Because the greatest common factor of 4 and 8 is 4. The greatest common factor of qr and r is just r, because that's the exponent that's, the variable that's in both terms, and it's the lowest exponent. So we have 4r. So 4qr divided by 4r is just q. 4 divided by 4 is 1, r divided by 4 is, r divided by r is 1, and then we have a q left over. And then 8r divided by 4r is plus 2. And now I'm going to do exactly the same thing for the second term, second group. Find the greatest common factor of this second binomial, 3q and 6. So the greatest common factor there would be just 3. So plus 3. And now 3q divided by 3 is q. And then 6 divided by 3 is 2, and q plus 2. And our goal is to get the same binomial, q plus 2 and q plus 2. We have one more step to go with this, though, because if 4r times q plus 2 plus 3 times q plus 2, that's the same as writing 4r plus 3 times q plus 2. Notice one more time. 4r plus 3 goes in the first binomial, and q plus 2 goes in the second binomial, and they're multiplied together. And if we did FOIL with those, we'd come up with 4qr plus 8r plus 3q plus 6. Once again, grouping into two binomials, finding the greatest common factor of each binomial, factoring out, and then simplifying. So here's the next example with a polynomial with 4 terms. Rn plus 5n minus r minus 5. Since I have 4 terms, I have to break them into two binomials. Here's the first one. Notice because I have a minus sign, because it's a minus sign, I'm going to put it inside the parentheses. If it was a plus sign, the plus sign would stay outside. Okay, and you're going to see why in a minute. So I've got Rn and 5n, and which is the greatest common factor? Just n. So Rn divided by n is just r, and then 5n divided by n is plus 5. Now here's why we did the other way. I've got negative r and negative 5. Well, you're thinking there's really no greatest common factor between r and 5, but there is a negative 1. So I need to factor out the negative 1 so that I can get r minus 5 as the other binomial. So negative r divided by negative 1 is positive r. And negative 5 divided by negative 1 is positive 5. So now I have n times the quantity of r plus 5 minus 1 times the quantity of r plus 5. So I take the n and the minus 1 and make that one binomial. And r plus 5 is the second binomial. And that is my final answer. And we're going to do one more example of a polynomial with 4 terms, because there's going to be a little snafu in here that we need to fix. Okay? So I've got 4 terms. I'm going to group them. Plus sign, so plus sign stays outside the parentheses. So now I'm going to find the greatest common factor between 2mk and 12m. The greatest common factor between 12 and 2 is 2. The greatest common factor between m and m is m. And there's not one because both of them both have k's. So we know our greatest common factor is 2m. So 2mk divided by 2m is just k. And negative 12m divided by 2m is minus 6. And now we're going to go over here and we have 42 and negative 7k. So the greatest common factor between 42 and negative 7k would be 7. So we're going to do plus 7. And then I have 42 divided by 7 is 6. And then negative 7k divided by 7 is negative k. And Houston, we have a problem. Because I have k minus 6 over here and 6 minus k over here. Those two are not the same. So we've got to do something to make them the same. I'm not going to touch this one. We're going to leave this one alone. We're going to look over here at the 7 and the 6 minus k. What can I do to the 6 minus k to make it look like k minus 6? You're right, I can multiply it by -1. So in this case, I'm going to multiply everything in here by -1 and this term by -1. And I'm going to get -7. And -1 times 6 is -6. Negative k times -1 is positive k. So it's actually going to end up k minus 6. It's called the additive inverse. I multiply by -1. So essentially what I did is, instead of factoring out a 7 from this, I factored out the -7. And 42 divided by -7 is -6. And -7k divided by -7 is k, so that my two binomials are exactly the same. So I have 2m times k minus 6 minus 7 times k minus 6. Put it together, and I have 2m minus 7 times the quantity of k minus 6. You won't see these very often, but you need to be prepared for them when you do. When these two are not exactly the same, I've got to multiply one of them by -1 so that they become the same. And then just keep going, and my final answer is 2m minus 7 times the quantity of k minus 6. And here are your two practice problems for tonight. The first one is 7u squared t squared plus 21ut squared minus ut. Find the greatest common factor, factor it out, and that's your answer. The second problem is 3np plus 15p minus 4n minus 20. This one you have to create two groups, factor out the greatest common factor for each group, and then combine them at the end. Take a picture of these practice problems when you're finished, submit it through Edmodo.